Hey guys, welcome to the very first video of my channel, DIY Elvin Productions. Today we're going to build a DIY air conditioner using an ice machine. This should give us unlimited ice production and hopefully unlimited cold air. Let's get to it. Let's start with this 120mm fan, computer fan. I got this from Amazon. I will have all the links of the parts I purchased in the description below. I like this fan because it's very powerful, as you saw in the intro, and it also has a speed control knob. This fan comes in a single, double, or a triple variation. I chose the triple variation so you can have the most air output. First, I have to disassemble by removing all the grills on the front and the back. Let me just mention at this time that I'm not sponsored nor affiliated with any of the products in this video. This is a PC Radiator water cooling system, 360mm by 120mm. This radiator adopts a 12-tube design to accelerate the water flow and achieve faster temperature dissipation. I'm attaching the fans in a way that it pulls air through the radiator. Initially, I tried to position them so it pushes the air through it, but the airflow was significantly slower compared to this arrangement. Now, this is where I attach, measure, and cut the tube fittings. After I finish connecting all the barb and plastic tube fittings, the radiator and fan blower setup is pretty much complete. Now, let's test the system performance. This is a 200-gallon-per-hour aquarium pump. Once again, the links to the products I'm using will be in the description below. For this part of the test, I'm just using a container with 3 frozen bottled waters and a gallon of refrigerated water. Once all the connections are made, we can then see how well the water pump works for this setup. As we can see here, I think the water flow is just perfect, not too fast and not too slow. This temperature sensor should tell us how cool the airflow gets in this current setup. I'm also attaching these streamers so we can see a visual of the airflow. My initial room air temperature here is about 80.4 degrees Fahrenheit. Yeah, it's hot in my room, that's why I'm making this DIY air conditioner. I'm trying to cool this room down without the use of a window AC, because it's very expensive to run continuously. Now let's see how cold this airflow can get. At about 2 minutes, the lowest temperature I got is 63.8 degrees. That is a 16.6 degree difference. The air flowing though definitely feels cooler than 63 degrees, and it feels really good. It could be that the placement of the sensor is not at a good location. I just want to note that the airflow didn't take that long to get cool. The cold air was instant. The thermometer just took that long to settle. Here, we can see the temperature slowly going up. The frozen bottled water was not sufficient to keep the water cold. The same thing will happen as well when using a bag of ice. You would have to consistently be adding ice to maintain the temperature. This is why I thought of using the small ice maker. This ice maker creates ice cubes continuously, 9 cubes every 7 minutes to be precise. So, I figured that if I remove the ice tray, the ice cubes will keep falling back to the water reservoir, thus further cooling the water continuously. This then will solve the problem of having to manually add ice to the system. This time around, I'm adding a temperature sensor to the water, so then we'll be able to closely monitor both air and water temperatures. This is the moment of truth. Let's find out. The airflow was instantly cold the moment I turned on the fan, even though the thermometer is taking a while to get down. It did not take long at all for the water temperature to start going up. At the 2-minute mark, the lowest temperature we got was 64.4 degrees for the air, while the water has risen up to 53.7 degrees. Now let's wait for the first set of ice cubes to fall into the water and see what happens. Just moments before the first set of ice cubes fell into the water, the airflow temperature was already back up to 77 degrees, while the water temperature was also very close at almost 76 degrees. It didn't take long at all for the temperatures to equalize. Watch how the temperature starts to drop the moment the ice cubes hit the water. Let's see how cool it can get and for how long it'll last. Again, at around 2 minutes, the coldest temperature we got for the airflow this time is only 74.6 degrees, while the water is at 70.8 degrees. That is not very cold at all. So the 9 pieces of ice cubes it added after 7 minutes of running was not even close to bringing the temperatures back down to the initial lowest temperatures we got from the beginning. And again, from here on out, the temperatures only start to get warmer. So here's my final thoughts about this experimental build. While the concept about this whole setup works, the cause of failure from this experiment was with the ice machine. Not that using an ice machine did not work. It was the volume and capacity and the speed of the ice making process that failed. It was simply not fast enough to keep up with the demands of the temperature exchange from the radiator. Maybe, if it dropped ice cubes every minute, it would have stood a chance. However, I learned that the radiator and fan setup was a success. That part worked flawlessly. There was sufficient airflow and the temperature exchange from the radiator was really good. I was very impressed with those results. I will use that same setup for future builds. I guess back to the drawing board it is. For a future video, would you like to see me try to use a mini fridge with a freezer compartment to make a DIY air conditioner? Let me know. Please like, subscribe, and share if you enjoyed this video. I love you guys and God bless. Thanks for watching and see you next time.